Welcome back to another explainer. Today, we're unlocking one of the absolute most powerful, laser-precise tools you can have in your coding arsenal, the JavaScript slice method. Think of it as the ultimate surgeon's scalpel for your data. Seriously, whether you're wrangling strings of text or organizing massive lists, getting a handle on slicing is a total game changer. Let's dive in. Okay, here's our blueprint for today. First, the art of extraction. Then, ground zero slicing rules. The slicing blueprint, collections and arrays, the golden rule, and finally, the ultimate slicing challenge. Let's jump right into section 1, the art of extraction, conquering data. So, whether you're trying to extract information from text strings or pull items from arrays, the slice method gives you total, absolute control over your start and stop points. And the best part? It works seamlessly across both of these core data structures. You literally learn it once, and then you can apply it everywhere with total precision. Moving on to section 2, ground zero slicing rules, starting from nothing. Now, if you look closely at how we measure Hello World, notice where the counting begins. In JavaScript, we don't start counting at 1. No way. It always begins at 0. Every single character in a string, yep, even those pesky blank spaces, is assigned a strict numerical index to mark its exact position. It's exactly like the individual ticks on a measuring tape. So the really crucial point here is zero-based indexing. It's a numbering scheme where the first element of a sequence gets assigned the index 0 rather than 1. Let me be clear, this isn't just a friendly suggestion, it's an unbending law in coding. Getting this locked in your brain right now is exactly what's going to prevent those notorious, frustrating off-by-1 errors that plague pretty much everyone when they first start manipulating data. All right, section 3, the slicing blueprint, mechanics of the cut. Here it is, your master coding blueprint. It's wonderfully simple, but man, is it effective. First, you just provide the data. Then, you attach the .slice method. Inside those little parentheses, you pass in up to 2 parameters separated by a comma. The start index, which tells the code exactly where the cut begins, and the end index, telling it where to stop. Executing this really just takes 2 steps. Step 1, identify your start index, which is always included in your cut. Step 2, identify your stop index. Now listen closely, because the absolute key takeaway here is that the end index acts as a hard boundary. The slice stops right before it. That means the element sitting at the end index itself is never ever included in your newly extracted data. Let's see this in action. If we use our blueprint and write text.slice 0, 4 on the word JavaScript, we start at index 0, grabbing the J. We keep going along the ruler up to, but remember, not including, the S at index 4. The extraction hits that hard stop right before the 4, and boom, it perfectly pulls out just the word Java. But hey, what if we want the rest of the word? Well, if we strategically leave out the end index entirely and just write text.slice 4, the tool gets smart. It automatically captures everything from our start point all the way until the very end of the string. It just runs right to the finish line, perfectly returning the word script. And that brings us to a fantastic twist. You can actually think backwards. By throwing in negative numbers, you can count from the end of the string, where -1 is always your final character. So if we do text.slice -6, -3, it starts 6 characters from the end at the S, and slices up to, but not including, the 3rd character from the end. That gives us skr. This is an absolute lifesaver when you need data from the end, but, you have no idea exactly how long the string actually is. Okay, time for a quick knowledge check. Let's test this out on the word programming. Pause the explainer for a second and see if you can solve these 3 scenarios in your head. All right, you got it? Slicing 0 to 3 gives us pro. Slicing 3 to 7 extracts gram, and slicing -4 to the end beautifully captures ming. How'd you do? Let's roll right into section 4, collections and arrays applying the logic. Check out how strings and arrays compare. The syntax mapping is completely identical. Whether you're slicing a text string from 0 to 4 or an array of individual letters from 0 to 4, the code doesn't change one bit. That's what makes the slice method a truly universal tool. It gives you infinite precision across your entire code base. Even though an array stores multiple separate values instead of just single text characters, the underlying ruler and indexing logic, it remains exactly the same. You just treat each distinct item inside the array as a single tick on the ruler. The first item is 0, the second item is 1, the third is 2, and so on. It's the exact same mental model. Let's apply this to an array of 4 fruits. Executing fruits.slice 0, 2 starts us at index 0, capturing apple. Then we move to index 1, capturing banana. And then, bam, we hit our hard stop right before index 2, which is cherry. So what do we get? A brand new array containing just apple and banana. And yes, your existing knowledge applies perfectly to all those edge cases too. Omitting the end index on a numbers array starting at index 2 easily grabs everything to the end, giving us 30, 40, and 50. Meanwhile, using that negative counting trick perfectly extracts items from the back of a colors array. Slicing from -3 up to -1 neatly grabs blue and green. I'm telling you, the logic really is bulletproof. Okay, section 5. The golden rule. Safety first. There is this brilliant kind of cloning chamber aspect to this tool. It perfectly illustrates our golden rule. The slice method is completely non-destructive. What does that actually mean? It means it never alters, mutates, or corrupts your original data source. Instead, it safely scans the data and returns a brand new, fresh copy of the requested section. This makes Slice incredibly safe to use in complex programs because your original arrays and strings are going to remain perfectly intact for other parts of your code. You literally can't accidentally break your original data. And finally, section 6, the ultimate slicing challenge. Test your skills. Are you ready for the ultimate slicing challenge? It's time to put all this theory into active practice and execute some precise extractions entirely on your own. We've got 3 target goals here: extracting script from JavaScript, pulling the last 3 items from an array, and grabbing the first 2 letters of a name. I highly encourage you to pause the explainer, grab a pen, and actually write out the exact terminal input required to hit these extractions. Seriously, try to solve them before peeking at the solutions. It's all about reinforcing those core syntax patterns in your brain. As we wrap up today's explainer, I'm going to leave you with this final kind of mind-bending puzzle. Think about an array holding the letters A through D. What happens when you combine your knowledge and slice from a standard index of 1 to a negative index of -1? Think about it. It skips the very first item, stops right before the very last item, and smartly returns just B and C from the middle. Mastering these precision tools and knowing how to seamlessly mix techniques exactly like this is what will make you a highly powerful, basically invincible coder. So knowing just how much precision you now have right at your fingertips, what data will you conquer next?